On the key concepts slide here, I have a direct translation of Newton's first law, stating every body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. I have stated here on my whiteboard section a few maybe more modern statements and different ways of stating it. Some get a little bit more mathematical type of statements here. This one up here says an object maintains its state of motion as long as no net force is applied to it. So both Newton's and this one are basically describing inertia. If you don't apply a force to something in a way that stops it, it's just going to keep moving the way it was. Or if it was starting at rest, it's going to remain at rest. We can state that a little bit more mathematically, though, in terms of this concept that was brought up here already as no net force. Well, no net force to a physicist is equivalent to saying the net force is equal to zero. Sometimes I've had some confusion come up, of the statement of like, well, if you say there is no net force, is that more like saying the net force is null set? I don't know if that it used to be a thing in algebra more often, but that's really, to a physicist, that just means net force is zero. What this opens up is the possibility that there are things, and we're going to look at some of these in the example, that could be moving in a way that is described by inertia, in other words, maintaining their state of motion with forces applied to them, but in such a way that the forces balance out so that the net force is equal to zero. And a mathematical way of stating that is when the net force is equal to zero, it implies the velocity maintains a constant value, which really is a value including direction. So it maintains both the constant magnitude and direction is implied by this statement. Maybe another way of stating it, though, is you could say, what does really net force mean? Well, the net force is the sum of external forces. So this is just another way of saying the same thing. And if that's equal to zero, that implies inertial motion. Well, inertial motion is also equivalent to saying that the velocity remains constant.